In this video we're going to look at the White heteroscedasticity test. This is a test for the null hypothesis that the variance in our regression equation is constant against the alternative hypothesis that the variance depends on the exogenous variable or higher powers of the exogenous variable. This particular example we're going to look at the exogenous variable and its squared value. The first stage is we need to set out the null and alternative hypotheses explicitly. Our null hypothesis is the expected value of the squared error for any value of I is equal to a constant gamma 0. The alternative hypothesis is that the expected value of ui squared is a function of the exogenous variable x and possibly higher powers, in this case the squared value of x. This gives us the White test. So how do we construct the test? Well, we can't observe the errors directly, but we can observe the regression residuals. So the regression residuals are defined by taking our regression model, estimating the coefficients alpha and beta so that we get alpha hat and beta hat, and then constructing a set of residuals of the form ui hat equals yi minus alpha hat minus beta hat xi. We can then use these regression residuals to construct an auxiliary regression of the form shown here, where we've got ui hat squared is a function of xi and xi squared, and we're going to estimate this auxiliary regression. So once we've estimated the auxiliary regression, then we note that under the null hypothesis we can take the output of the auxiliary regression and construct a test statistic for the null hypothesis that the variance is constant. And that test statistic is equal to nr squared, where n is the number of observations and r squared is the coefficient of determination. That's distributed as chi-squared with 2 degrees of freedom. So let's look at a particular example of how we construct this test. First of all, we're going to estimate a regression model which links consumption per head to GDP per head for a cross-section of 209 countries. This is what we get when we estimate the regression equation. Now we want to test for heteroscedasticity, so we're going to base that on the regression residuals, which are given here as resid. Now we need to define the squared regression residuals, which here are ESQ as the regression residuals to the power 2. And we also need to define the squared value of the exogenous variable as GDP to the power 2. Now we can run our auxiliary regression. So our auxiliary regression takes the form of a regression of the squared regression residuals on a constant, the original exogenous variable and its squared value. And this gives us the information we need to calculate the White test. We've got the number of observations 209, the r squared 0.3084. So the final stage is we need to construct our test statistic. So we construct our test statistic from this information. We've got nr squared here is equal to 209 multiplied by 0.3084. That gives us a value of 64.46. Now we know that approximately for a chi-squared distribution with 2 degrees of freedom, the 5% critical value is about 5.9, so this is obviously going to reject the null. But to show this formally, we can calculate the p-value using the following utility. So here we take our test statistic, which in this case is 64.46, and for a chi-squared distribution with 2 degrees of freedom, then we can calculate the p-value, and in this case the p-value to 4 decimal places is 0. So it's way out in the tail of the distribution, and we would reject the null hypothesis in this case.